Hello all, November 7th, 2013. Let me just go right over to the board. Okay, I wanted to thank everybody for your comments on all the videos, especially the last one. Beefy0987 gave me a compliment and said I was more of a barometer for him, and he prefers the peak oil news than most of the others, but he likes the videos. Thank you for the comment. I would try to pronounce this, but I can't, so I'm not going to. He wanted me to put dates on the titles, and we'll be glad to do that. Okay, 88 gave me a Google search to look up San Francisco-based ships in the bay, and I did that, and I appreciate that. And Destroy for new, or for now, new, I don't know. Anyway, he talks about how the planet is coming due for a lack of food. Yeah, we'll see where the food ends up. And Russell Shute talks about how he prefers videos that are on the economics of the U.S. and how things are going, and it looks like we may be on a downturn. I agree with him. I think that the auto market, even though a lot of places are saying that autos are doing well, others are saying autos are doing terrible. So anyway, I appreciate it. And Paulo Montero said he was surprised that I was back talking about peak oil. Every now and then I will do an update on peak oil. It's just that our government, the U.S., does not want people talking about peak oil or fracking or any of that sort of thing. They find it that you're kind of being a terrorist if you do that. So every now and then I will. And Mr. Energy Czar, he talks about how whatever oil we don't use, China will. That's so true. There's no shortages of buyers of oil. And thank you very much for all the comments. And the guess for the board number was 12. So far that's the only number guess we have today. We'll find out how close he was, or whether he was right on, at the end of this video. Okay, let's talk about what is happening on the planet. Okay, the World Meteorological Organization, I have trouble with that word, don't you? Says that the CO2 count in the world is now increasing to a record high of 393.1 parts per million from a pre-industrial time of 278. So we're going up rapidly on the CO2 count. It's not this slow thing like they showed. It really is. It was pre-industrial, stayed pretty much the same, and once we got there, we're doing this at 393.1 parts per million. Let's go take a little deeper look at that. And we're at one of our stops, and I wanted to show you this cloud formation. Pretty amazing. No rain. Here it is, November. It's probably 65, 63 out. Very warm. We were supposed to have rain today, but as you can see, a blue sky. Well, what are the greenhouse gases and how does that work? Okay, number 1 is water vapor. Number 2 is carbon dioxide, CO2. Number 3 is methane, CH4. Number 4 is nitrous oxide, N2O. And number 5 is CFCs, the refrigerant. It's not that important that you remember any of that. Now let's talk about water real quickly. Water is a greenhouse gas when it's in a vapor form that you can't see. What it does is the sun brings in heat to the planet, and the water vapor, the more there is, the more the heat stays in along the earth and gets trapped by all the water vapor. However, if water vapor is in the form of clouds, then the sun gets reflected and it gets cooler down here. So it works opposite of the way it works when it's a vapor. But so water vapor is a greenhouse gas, but it counteracts the greenhouse gas effect. Okay, carbon dioxide. Boy, that's the worst one. That's also a gas, CO2, and it works like this. There's all this CO2 in the air, and the sun rays comes in and then bounces off the earth, bounces off the CO2 and back to the planet. So it does this kind of thing, so that the heat builds up in the atmosphere. And CO2 numbers have a season. They go up and down as a season. During the winter they go down, during the summer they go up. What about that methane, CH4? CH4 is a constant, works just like CO2, basically. The sun comes in, reflects, comes back down to Earth. But is a much worse greenhouse gas than CO2. It sticks around a lot less than carbon dioxide. And what about nitrous oxide? Well, nitrogen is what is a completely neutral. However, nitrous oxide has a different story. Let me show you. Okay, when CO mixes with CH4, which is methane, they combine basically a greenhouse gas. And again, the sun comes in, hits, bounces off the new chemical and back down to Earth. So that also is called an indirect method of when two chemicals mix and make their own greenhouse gas, and then it can even turn into ozone, and that also is a greenhouse gas. Now, most of these greenhouse gases are pretty short-lived. There's one gas that lasts for a long time and is causing the most problem with the greenhouse effect. Let me show you. Hey, the eraser's doing real well. Look at that. It's still going strong. Okay, we're sort of at the end of the ride. I just wanted to show you some more cloud formations on this wonderful day. It's just been so warm and nice. Not too hot. Probably 71 at the most right now. Let's take a look at this. The concentrations, let's look at that. Water vapor is between 36 and 72% of all greenhouse gases. The warmer the planet, the more water vapor, the more warming. Carbon dioxide, CO2, is between 9 and 26% of all greenhouse gases. The more carbon dioxide, the more heating of the planet. Methane, CH4, is between 4 and 9%. The more of that, the more greenhouse gas. Ozone, O3, is 3 to 7%. But what's the lifespan of these? Now this is where it gets real complicated. To measure the lifespan of a gas inside the atmosphere is complicated to such a degree I don't really understand it a whole lot. So what I've done is tried to make it more simplified by giving you a year, how many years it lasts in our atmosphere and what happens to it. Let me show you. Okay, it's real easy to say carbon dioxide lasts for 100 years plus. Methane will last about 12 years, and nitrous oxide is about 114 years. But that's simplifying things, because carbon dioxide can actually last over 1,000,000 years, and that's why carbon dioxide is such a powerful greenhouse gas. Even though methane is much more powerful, it doesn't last. It turns into water vapor through chemical reaction, and it only lasts at its highest level for 12 years, and then it decreases into water vapor, which is also a greenhouse gas, which just slowly will last forever. It just slowly goes up if the planet's warmer, or it goes down if the planet's cooler. Nitrous oxide, there isn't very much of it, but it'll last about 114 years. But let's talk about the CO2, since that's what most people talk about, and the reason is because of how long it can last. CO2 does this season to season. It goes up and down in parts per million. This is pre-industrial age, this is now. Alright, so what science does is they just take an average, which is like that. That's fine up until not too long ago, and then it started doing this. It just started rising very quickly. The carbon dioxide, what happens to it, it goes into the oceans, it goes into the plants and animals, it goes down into the bottom of the sea and freezes out, and that's how come CO2 will go down. But it also goes up. Now, if the planet becomes more churned up from the heat, CO2 will stay in the atmosphere longer. So instead of 100 years, it may last 1,000,000 years. So that's why they say we will never see this type of planet again, what we saw when we were children. It will always be hotter now, because it may take 1,000,000 years to get rid of all this. Now, CO2 is a constant. There's just so much carbon on the planet. It's always the same. It's just where it's stored. If it's stored at the bottom of the ocean in ice, it's not in the atmosphere, causing greenhouse effect. So as soon as the oceans warm up, by the way, the more carbon dioxide there is, the more acid the oceans begin to get. So all this carbon dioxide is being put into the water, and then eventually goes down into where it freezes out at the bottom of the cold oceans, and there's that damn truck again. It's the street sweeper. We've had trouble with that many times in the past. It just keeps going back and forth. There's so many sources of CO2 besides industrial. Every time you take a breath and blow it out, you're putting in CO2. Every time a volcano erupts, it's putting out CO2. Every time you drive your car, it's putting out CO2. And all this CO2 is going into our atmosphere. So that's why you want to do as least amount of harm to our planet by putting CO2, carbon dioxide, into the atmosphere. It's a one-way street. There's no going back. We won't live to see this ever go back down. It will from now on get warmer and warmer and warmer during the winters, and the northern and the southern hemispheres of the planet, eventually getting warmer in the more towards the center, but probably not in our lifetime. What does too much CO2 cause? It causes the melting of the ice sheets around the world. Ice sheets act, let's say there's a big ice sheet here and a big ice sheet here, and the sun is coming in, it will reflect off into space. Whereas when there's no ice, this area is darker, and the sun's rays goes right into it and starts to heat the thing up like a black or dark rock during a hot day. It just holds in the heat. Same with the ice. Ice reflects heat, dark colors absorb heat. The more dark colors, the less ice, there's more dark colors, and the hotter our climate gets. Even if the climate deniers say this is all bullshit, then they have to not understand how planes fly or how we breathe or anything like that. And let me just show you real quickly, and then we'll finish up this video. Okay, now what we have to do is we have to get into what is a molecule of CO2, a molecule of nitrogen, or a molecule of methane, or a molecule of water vapor. Let me show you. The board's really getting a workout today. Okay, this is our atmosphere. It's about up to here, and this is us. Here's a tree. Okay, our atmosphere is not a vacuum, so that means that there's molecules filling the space. Whole bunch of them, just the whole area. If you could see a molecule, you would just see the whole place full of molecules. And what these do, most of our atmosphere is made of nitrogen. Alright, nitrogen has no effect on sunlight. It just comes in, hits the ground, and that's it. And whatever's down here influences. But nitrogen itself is absolutely neutral. But carbon dioxide is mixed in at a percentage. Alright, so the more carbon dioxide, the sun will come in, hit the ground, come up, hit the CO2 particle, and come down and heat up the ground to a high temperature. That's how that works. So the more parts per million you get of CO2, the more you're going to end up with this effect, and the heat comes in and just starts building and building. A good example of this is Venus, where Venus has an atmosphere mostly of CO2. some nitrogen, and some other chemicals. So almost all of the rays from the sun comes in, goes up, hits, and comes back down on the planet Venus. And that's why you get 800 degree temperatures on Venus, 800 to 900 degree temperatures on Venus, because of the greenhouse effect. If we did not have CO2, all that would happen was you would have a very cold planet, because most of it would just go back out into space, and you would end up with a frozen ice ball called Earth. But because we have CO2, we have a comfortable we have a livable temperature here on planet Earth. I know that was really complicated, but please just go and read a little bit up on it. If you don't believe it, go look up what happens on Venus, what happens on Earth. Just look up atmosphere makeup, and you'll get the story on it. You'll see how complicated it is. But global climate change is happening. It is caused by humans putting in things like CO2 and nitrous oxide and methane and other chemicals that are greenhouse gases that just don't last as long as CO2. That's why we pay attention to CO2 so much. Now, let's go find out what that number is. Okay, Paul Montero, guess 12 from 10 to 99. The actual number is 10. It looks like most of us are ready for the bourdons. So I guess we won't bother with any more numbers. People don't seem to be too interested in it right at the moment. Okay, I don't really understand the +1 system, because I don't belong to anything with Google because of the spying. In fact, I use DuckDuckGo instead of Google to look up things. That way they can't spy on you. And I think we've had enough of these big corporations spying on us, giving our information to the government. So I just don't know what all that is, but I appreciate it if you, whatever it is, the plus or whatever it is. Thanks a lot. Okay, on the end of a beautiful day, still warm, nice. We'll see you guys next time.